Hi, my name is Avani Joshi, and today I'll be demonstrating how to solve question number 8 on page 283 of the McGraw-Hill-Ryerson Calculus textbook. Question number 8. The value of an investment is modeled by the equation A at t is equal to A multiplied by e to the power of 0.05t, where A is the amount the investment is worth after t years, and O is the initial amount invested. A. If the initial amount invested was $3,000, what is the value of the investment after I, 2 years, II, 5 years, and III, 25 years? B. How long will it take for this investment to double in value? And C. At what rate is the investment growing at the time when its value has doubled? The calculus concepts we will be focusing on is the natural log, the derivative of the natural log, the derivative of composite, and ln. Highlighted in green is the equation we must use throughout the question. Highlighted in yellow represents the variables in the equation. Highlighted in pink is what AO represents. Part 1 of the question requires us to find the value of the investment after a certain amount of time if the initial investment was $3,000. Part 2 requires us to find how long it will take for this investment to double in value, which is highlighted in pink. And highlighted in orange, the third part requires us to find what rate the investment is growing when the value has doubled.
As we see, the graph is on an upwards trend, meaning that as t increases, the investment will increase. The green star represents the initial investment. The blue star represents when t is 2. The red star represents when t is 5. And the orange star represents when the investment has doubled, so when the investment is $6,000.
To solve for A, if the initial investment was $3,000, what is the value of the investment after 2, 5, and 25 years? We must sub in the values 2, 5, and 25 for t into the equation A at t is equal to AO multiplied by e to the power 0.065t to find the initial investment. To understand B, how long will it take for this investment to double in value, we must understand 3 parts. E, which is Euler's constant, a number between 2.71 and 2.72. Part 2, what ln is, which is log base e to the x. It's also called natural log. Part 3, the fact that the inverse of e to the power of x is ln to the x. So for example, if 2 is equal to e to the power of 5t, we must use ln x, which is the inverse of e to x, to bring down 5t and solve for t. We would then get ln of 2 is equal to 5t. Divide both sides by 5, and you would get the answer t, which is 0.139. To solve C, at which rate is the investment growing at the time when its value has doubled, we must understand that when a question has rate in it, it is referring to the derivative. The derivative is a way to represent rate of change, the amount at which a function is changing at one given point. We must also understand that if a function is e to the power of x, its derivative is also e to the power of x. This is one special case. And thirdly, if the function is e to the power of g of x, the derivative is e to the power of g of x multiplied by g prime of x. A, if the initial investment is $3,000, what is the value of the investment after 2 years? To solve this, we can use the equation A at t is equal to AO multiplied by e to the power of 0.0625t. We sub in 2 for t and 3,000 for AO being the initial amount. The answer we get is 3,416.48515. Therefore, if the initial investment is $3,000, the value of the investment is $3,416.49 after 2 years. To solve the second part of A, 5 years, we should plug in 5 years into the equation A at t is equal to AO multiplied by e to the power of 0.065t and 3,000 into AO, which would give us the answer of 4,152.091938. Therefore, if the initial investment is $3,000, the value of the investment is $4,152.09 after 5 years. In part 3 of A, 25 years, in order to solve this, you must sub in 25 for t into A at t is equal to AO multiplied by e to the power of 0.065t and 3,000 into AO to get the answer of 15,235.25711. Therefore, if the initial value of the investment is $3,000, the value of the investment is $15,235.26 after 25 years. B. How long will it take for the investment to double in value? We know the initial amount, which is $3,000, and for it to double in value, it would be $6,000. We can use the equation A at t is equal to AO multiplied by e to the power of 0.065t. So we know we need to find t when it equals to $6,000. In order to do this, we need to sub in 6,000 into A at t and 3,000 into the initial amount to find it. To quickly recap, in order to find the x in e of x, we must use the inverse, which is ln of x. The first step, because there's a 3,000 in front of the e of x, we must divide the whole equation by 3,000 on both sides. This would give us 2 is equal to e to the power of 0.065t. We would then use the inverse of e, which is ln, giving us ln 2 is equal to 0.065t. And lastly, divide both sides by 0.065, giving us a total amount of 10.66380278, which is equal to t. Therefore, it will take about 10.7 years for this investment of $3,000 to double in value. And C, at what rate is the investment growing at the time when its value has doubled? In this case, we are going to use A at t is equal to AO multiplied by e to the power of 0.065t. We know the initial value, which is 3,000. We can sub that into AO. We must find the derivative. To recap, if the function is f of x is equal to e to the power of g of x, the derivative is f prime x is equal to e to the power of g of x multiplied by g prime of x. We know that in this case, our function is f of x is equal to e to the power of g of x. Therefore, the derivative of this function is a prime t is equal to 3,000 multiplied by e to the power of 0.065t multiplied by 0.065. Multiplying 3,000 by 0.065, we get 195 multiplied by e to the power of 0.065t. We need to find at what rate the investment is growing when the investment has doubled in value, which is 10.66380278 years. We then plug in that value into t, which gives us an equation at a prime t is equal to 195 multiplied by e to the power of 0.065 multiplied by 10.66380278. We then get 195 multiplied by 2, which gives us a final answer of 390. Therefore, the investment will grow at a rate of $390 per year at the time when its value has doubled. Congratulations, you made it! You now know the basic calculus concepts, natural log, e, the derivative of e, and a derivative composite. But now what? What are you going to do with this newfound information?
A career we can apply to this concept is stock market analyst. A stock market analyst must focus on the rate of change of the stocks. If it is on an upward trend and all of a sudden the rate of change approaches zero, then we must know that we should short or sell the stock in order to prevent losing any money.